So you would like to know if it's possible for us to reverse the process of implicit differentiation, meaning if you have the derivative after implicit differentiation, is it possible to somehow go backwards and figure out what the original equation is? Well, I will tell you yes, but it's not always going to be easy. For this one, it's pretty manageable, so let's have a look. Before we start, I want to tell you, I have to attach a condition right here so that later on we can solve for the unknown constant c. Just keep that in mind, y of 0 is equal to -1. And in fact, when you do this, you're actually just solving a differential equation because this is an equation with derivative. Anyway, here we go. First, notice we have y squared, and then this is x to the first, y to the first, and then y squared, x to the first, y to the first, and then x squared. Notice each term has degree 2, right? Power here is 2, and then 1 plus 1, 2, likewise 1 plus 1 is 2. Whenever we have this is called a homogeneous differential equation. Then you can solve it by doing the first step right here, which is we'll divide the top and bottom by x squared. And then we'll do a substitution later on, and it will become separable. For now, if you try to separate it, I don't think so. But if you do this and then do a substitution, it will be separable. So let's have a look. dy dx equals this divided by that, I will write it as 2 and then y over x and then squared. Continue minus this over that, well, it's just x on the bottom. We have y over x over this over that, which is just y over x squared. Continue, that's plus y over x, and then lastly it's just -1. Pretty nice. Now have a look. The substitution is we can let u, or you can use v, doesn't matter, or t, seriously doesn't matter. U equal the input, which is y over x. And then you do the usual business. If you let u equal this, notice we have dy dx. So I'm just going to multiply both sides by x, so we get y is equal to x times u. And then we are going to take the derivative with respect to x. The left hand side will give us dy dx. And now on the right hand side, x is the independent variable, u is a function in terms of x, because u is equal to y over x. We need the product rule. I will keep the first function, which is x, and then we multiply by the derivative u with respect to x, which is du dx. And we add the second function, u, and we multiply by the derivative x with respect to x, which is just equal to 1. So now, this right here will be dy dx, which we have x du dx, and then plus u times 1, which is just plus u, and that's equal to all that, and I'll just change this to u, and then minus u over u, and then u, and then u, and no, just -1, just kidding. Okay, now for the right hand side here, you will just kind of have to do some algebra. Let's bring this to the other side and then combine in terms of all that stuff. So we get x du dx, it's equal to 2u squared minus u over u squared plus u minus 1, and then this is going to be minus u, and then get a common denominator, which is that. So say u squared plus u minus 1, u squared plus u minus 1. So that it's actually negative u cubed, and then minus u squared, and then minus u plus u, and then minus u plus u is just 0. Pretty nice. And then combine this and that. Okay, so now we get x du dx, it's equal to, okay, on the top I'm just going to write 2u squared minus u squared as u squared, and then I will write down minus u cubed over the denominator, u squared plus u minus 1. And now I'll tell you, after the substitution and the clean up, this equation is separable, meaning you can put all the u's together on one side with the du, and all the x together on the other side with the dx. So let's go ahead and make that happen. So first, you might be wondering, can we just divide both sides by du so that this and then du are on one side? But no, don't do that, because you should not have the differential on the bottom. At least I don't know how to handle that. Therefore, I am going to multiply both sides by dx and then divide both sides by x, and then I will multiply the reciprocal of this, both sides. So this will be on the top, this will be on the bottom. We get u squared plus u minus 1 over, this right here, it looks like I should factor it, right? So let's just go ahead and just factor that. It's just almost like a second nature. When you see something like that, just go ahead and factor it. But anyways, you'll see it's like we're about to do some partial fractions. But anyway, this right here, we have the du, and then remember dx here, and then dx on the bottom, so 1 over x. Ta-da, this is it. We just separate this differential equation. Now, this right here, it looks like we have to do some tedious partial fractions. No, not really, because notice how this and that are very similar and this and that are the same. So this is what we can do. I'm actually going to separate the fractions like this. U squared over u squared and then times 1 minus u, right? Just this term over the denominator plus these two terms, u minus 1 over the same denominator, u squared 1 minus u. So they have all this and then multiply du, and the right hand side stays the same. Now check this out. Cancel, cancel. 1 over 1 minus u. This right here, well, technically you have to flip this or flip that, doesn't matter. I will factor out negative and then do 1 minus u, and then we can cancel this and that. So we get negative 1 over u squared. Very nice, huh? So this right here, 1 over 1 minus u minus 1 over u squared du, and then that's equal to 1 over x dx. Now we are ready to integrate both sides. Be careful, we have a linear term on the bottom, 1 minus u to the first power. We do get natural log absolute value of 1 minus u, but remember to divide it by the coefficient of u, which is negative 1. So that will make this negative. Because of the chain rule, if you do a substitution, right, the derivative of this is negative 1. So you have to divide it by that, which is the same as multiply by negative. Yeah, just be aware of that. And then minus 1 over u squared, if you integrate that, you get negative 1 over u. With this negative, you get positive. So that's the integral for that. Don't worry about the plus c, just do it on the right hand side, because if you have a plus c here, well, that's plus c1 and this is plus c2. Combine them, it's another constant. Just put on plus c on the right hand side. Okay, this right here, ln absolute value of x, and then here we go, plus c1. Right here, I will actually plug in y over x back to the u, so we have negative ln absolute value of 1 minus y over x plus, this is 1 over u, so we get x over y, and then we still have the rest. And then I'm going to simplify this term a little bit on the side for you guys real quick. Note that that is going to be negative ln, get the common denominator, so that's x over x. So it's like this, and then we can simplify it, log property. So this is negative ln of the top minus ln of the bottom, and then distribute. So you get negative ln absolute value of x minus y, and then plus ln absolute value of x, and then the rest stays the same. And then let's say still c1 right here. So from here, we see that ln absolute value of x on both sides, we can get rid of them. And then I'm going to move this term to the other side. So we have negative ln absolute value of x minus y. It's equal to negative x over y plus c1. And then let's just do the usual business. Let's multiply everybody by negative 1. So we get positive ln absolute value x minus y. And that will be positive x over y. But now check this out. C1's a constant. Negative C1 is also a constant. So I will just write it as C2, a new constant. Yes. And then let's get rid of the natural log. We exponentiate both sides like so. So you can see, haha, we have this part right here, huh? So that will give us absolute value of x minus y equals, okay, we have a sum in the exponent because we do it e to this power. So technically we will have e to the x over y, and you multiply that by e to the c2 power. But here we go again. C2 is a constant, e is a constant to a constant is just another constant. So I'm going to replace this with C3. And I like to put the C3 in the front as well. Okay, then we are going to get rid of the absolute value, and to do so, you can just really get rid of it. But don't forget to put a plus or minus on the other side. And now we have x minus y is equal to, here we go again. Positive C3 is a constant, negative C3 is also a constant, so I'm just going to group them as another constant, call it C4. And then we have e to the x over y power. And this is pretty much it. You have a general solution to that differential equation. But now remember, the initial condition I imposed was that y of 0 is equal to negative 1. So that means if you plug in x is equal to 0, you should end up y giving you negative 1. So go ahead and do that. That will be 0 minus negative 1, and that's equal to c4, and then e to the 0 over negative 1. So the left hand side is just 1, and then we have c4, and e to the 0th power is just 1. So we see c4 is equal to 1. That means we have the equation x minus y is equal to 1 times e to the x over y. And this is the original equation that we started. That's it.